Thank you. My name is Jörg Minnerup. So I'm a member of various committees and bodies, ZVI, and so on and so forth. AAT3, outdoor lighting, from the German to the European lighting technology. I am an expert when it comes to outdoor lighting. Referring to, I would like to put a focus on street lighting today, streetlights today, and what's being discussed there at the moment without knowing that's already part of the standard. So the streetlight standard is made up of 5 different parts. The first one is a purely German part, a selection of lighting classes, quality characteristics, calculations of quality characteristics, quality properties, methods to measuring the quality characteristics of streetlights, and energy efficiency indicators. A selection of lighting classes. What is written in the standard and what is not? Well, traffic areas, adjacent areas, conflicting areas are described, areas without traffic, and boundary areas. What is not included for example, residential streets, residential roads, and the roads that are defined by the RASt. And they are mentioned in the 13201, but they are not described in detail. For example, pedestrian crossings, there's specific standards for that, but there is no information included in the actual standard on these roads. So, for example, a residential area road. If it's classified as a residential area road, you have to think about what this actually means. And there are certain regulations on that, what are certain properties defining those areas. What about the widths? What about the properties? This is not part of the standard. You could get the information from the RASt or also from other publications. What is part of the standard? It is this table that you can see here. So this includes a table on how to select the lighting classes. The first 3 ones in black are measured on the or based on the intensity of lighting. And the first 3 on the luminance, on the brightness, on the light density. Main roads, I think I can skip that. We've heard about that a lot. The standard was written in 2021. You might have come along this if you have dealt with streetlights. And the same goes for light density, for illuminance, different categories that you can select and that you can use. Different lighting classes for different times of the day, and you find all the information in these tables. Bike paths, public spaces, public squares. And then you've got tables where you take your lighting class, and here you find the information on the illuminance, on the required illuminance for the road that you selected or that you want to illuminate. Evenness, density, minimum intensity, conflicting areas, minimum values. So you find all the information in those tables. This is being discussed at European level as well. For example, for IP classes, for residential roads, for example. So everything that's evaluated based on the illuminance level instead of the minimum illuminance, whether you just add an even value for everything or replace it with an even value. So this is being discussed at the moment. Well, we have to wait and see what is coming out of that. What will be the result of the discussion about the German part 1 of the standard? What is included here? I keep on pointing that out all the time. Adaptive lighting is becoming more and more important. What does that mean, adaptive lighting? The right light, the right level of light, the right light intensity at the right time of the day in the right space. This is the adaptation lighting, the so-called adaptation lighting. And here you can see that different criteria are being used or can be used to define the lighting classes, the lighting class at a certain time of the day. Speed, for example, traffic. What about the composition of the traffic? What about the light density of the surrounding, of the ambient area? Do you want to be able to recognize faces of people passing by? What about the weather conditions? It is raining more and more often, also in Germany. And we know that there are different light distributions of lights. For example, if the road is wet or if it's dry, it depends on if it's wet or if it's dry. And then there are environmental influences as well. We've got a Environmental Protection Act, which was passed by the national government. We've already got this in place. But we have to wait for the implementation regulation until the beginning of 2025, obviously, because the Federal Ministry for the Environment was given the task to also write a regulation on the act, accompanying the act. And in September of last year, they were asked to do this, and now they've got 2 years to propose a regulation or propose the text of the ordinance, and then we will have to wait and see what will be implemented. But I don't think that this will happen before 2026. What we should never forget, and this happens quite often in today's discussion, where we got hardcore activists fighting for their cause, for their topic. They forget to take into account the overall picture, to have a look at the overall picture. And if I am a human being living in a city and I really want to experience city life in the afternoon and the weekends, if I want to sit somewhere in an area and really want to feel the urban life, in a restaurant, for example, I want to be able to also see the building in front or behind me. So you really want to see the facade of houses as well, also at night. If you would implement it the way many people would like it, that no light goes out in the atmosphere, you would not even be able to recognize the upper parts of the building. They would be just black. It would just create like a tunnel effect, and you only could see half of the building. But if you are somebody who is living in the city, if you love city light, you want to see the entire building, not all night long, of course, but temporarily. For example, you could switch out the lights temporarily during the night, and this is possible with adaptive lighting. And I want this to be possible. There are products on the market who make this possible, that make this possible. Well, if you don't want to experience city life or urban life, it's okay, but there are many people who want to really experience nightlife in the cities. What's not included in the standard are adaptation paths, for example, or if you, for example, leave a city and you come from full lighting of a main road to dark areas or areas of zero lighting with just moonlight, if you can see it with all those clouds, then at the end of a lighted road, you should phase out the lighting. You should dim it. This is also possible with LED lighting. This is no problem at all. And this is one example how you could do this. It, of course, also depends on the allowed maximum speed. But this is something that you should keep in mind. Another thing that the standard is missing are examples on how to illuminate a bike road, for example, bike track. So if, for example, a cycle path. So, well, there should also be other technical solutions apart from the own light from the light of the bike. So if somebody is riding the bike at night on this cycle path, for example, you could, for example, install a light that reacts to the movements of the cyclist, that follows the cyclists. So this is also adaptive lighting. As soon as the cyclist has passed by, the light will switch off again. What is also not included in the standard is well, it's included in the illuminance levels. And this is what people always tend to forget. Of course, well, there is a certain scientific basis on the illuminance levels. And this has to do with perception. And if you take this seriously, then this is one example that I brought you. On the left side, you see the density, the required density that is needed to really be able to see things. For example, if you get an evenness of 0.4, with a low level of glare, this value that you can see here on the slide is sufficient. But if you are at 0.2 only instead of 0.4, then you need 3 candela per square meter in order to be able to see the same things. And this is sometimes this is something that people sometimes forget. And the same goes for a higher glare level. Here you've got the evenness, the same evenness, but you've got a higher glare level, and maybe a product that is worse in terms of quality, or it might be the wrong product or the wrong use case, the wrong application. So here you've got a low glare level, 1 candela per square meter, as we have it on the left side. But if you've got a light with less with a lower value, then you need 2 candela per square meter in order to be able to see the same object properly in the same space. What is behind it? If the glare level is higher, more stray light meets your eye, meets your retina, and then the object shifts, as you can see on the left side. This black point that you can see on the curve shifts to the right side or moves to the right side. And if the intensity is not increased, then you don't recognize that person anymore, or the rabbit, or whatever. So it's not visible anymore. And then the result might be an accident. So you have to increase the light intensity in order to be able to see it properly again. This is another example. Here we are. This is a good example. Those are pictures from the Technical University of Berlin about measurements they have carried out. And on the left side, You see 0.2 candela per square meters. H is and a low level, and on the right side you see a road with 1 candela per square meter. So the difference is clear to see. But what's even clearer to see is on the next picture. This is a picture at day, but the effect would be the same at night. You see a child with a yellow rain jacket standing on the pedestrian crossing in front of the tree. Let me ask you let me be a bit provocative. I would like to ask you, what do you see here? A child with a black jacket or with black clothes standing in the same spot. And the environment, the tree, everything is dark. The ambient environment is dark. So there is no contrast, or the contrast of the clothes not big enough. And we've got exactly the same effect at night. And if you get older, this effect becomes more critical. This has to do with the fact that your eyes get worse if you get older. And this is part of all the discussions. This is not taken into account enough in the discussions. The question is, do we need enough light? Do we need that amount of light? But things like that, aspects like that are not taken into account at all. There are persons who say, I can see that, so it's fine, but they have no knowledge, no information at all about the actual perception conditions that we've been dealing with for years. So we do this for outdoor lighting and also for interior lighting, and we write the standards the way they are. Or they write the standards the way they are, and they forget to include all those aspects. Are there other influences that are not included in the standard? Yes, of course. The 74% is so, for example, recognizability, visual acuity, light colors, other drivers that are driving slower, accident rates, velocities, peripheral views. So I heard that there is no evidence for the fact that the number of accidents is increasing with a lower level of illuminance. But this is absolutely absurd. There are surveys in Berlin, trials or studies from Berlin and from the US. Of course, you have to take a look at all the surveys and analysis that have been carried out. So not only the ones that you like. Well, you have to look at the big picture, of course. I already made it clear before. Is half of the standard enough? I already said no, definitely not. We have to think about what we need and what we don't need. And of course, you have to take into account the recognizability of different objects at different times of the day. Did you know that the illuminance levels are measured based on people that are 25 years old? Yes, studies are done at universities, are carried out at universities with students, of course, and you know the age of the average student. The illuminance levels in the standards were based on white light of the HQL lamps initially. If not, now you know it. So if you take into account white light, it's pretty much identical with yellow light, warm white LEDs. But for the peripheral light, cool white light colors are necessary to recognize 1 second earlier what's happening in the boundary areas. So you can see it earlier than with yellow light, and you can maybe prevent an accident. This was also a question that I was asked on Sunday, but nobody could prove, they said that nobody could prove that we need white light. The light color has an influence on the recognizability, on the speed of recognition in the peripheral areas. I haven't seen any survey or any study that's been carried out in detail who says that warm white light is better for insects than cold white. And the light color, in the end, plays only a very, very minor role when it comes to its effects on insects. Certain times of the day and the intensity of light plays an important role here. This is what I wanted to tell you today in my presentation. Of course, there are also other standards, but I wanted to refer to street lights today, to street lighting today. Thank you very much for your attention. Thank you. Thanks for your presentation. Maybe there are some questions from the audience. Are there any relevant standards for outdoor lighting in buildings or facades? Are you also familiar with that? Well, there are no real standards, but recommendations. Well, for buildings, this depends on the types of building surfaces, on the colors, on many different. This depends on many different aspects. Well, for example, a sandstone facade. I wouldn't use cool white lighting for that facade, of course. Well, there are documents with recommendations, but there are no special standards. Well, you said sandstone. We've got wooden surfaces, wooden facades. We've got white facades. And this is something that you have to keep in mind when you do the lighting planning. Well, because light and color go hand in hand. Thank you.